Hi, let's take a look at some problems from the last section in Chapter 4. These problems correspond with Section 5.5 in your textbook, but they link well with material from Chapter 4, so they are part of that chapter. This is coded Chapter 4, Additional Number Sense. In this last section, we review the properties such as commutative property, associative property, closure, inverse, and identity. Let's briefly walk through those before we try to solve these problems. First of all, let's talk about the closure property. The closure property means that whatever set you start working with, such as natural numbers, you end working with. So, for example, if you are adding integers, do you end up getting another integer? Do you stay inside the same set? The answer is yes. However, if you are dividing integers, such as 2 and 10, you do not end up inside the same set because 2 divided by 10 is a rational value, so that's not an integer, so we would say that set is not closed under division. The second property we're going to take a look at is the commutative property. The commutative property exists for both addition and multiplication. For addition, you're familiar with it, such as a plus b equals b plus a. 3 plus 4 is the same as 4 plus 3. For multiplication, 3 times 4 is the same as 4 times 3, or a times b equals b times a. The associative property is basically kind of the same thing, except you're looking at 3 terms and you're using parentheses to group them. So a times b times c is the same as b times c times a, or a plus b plus c is the same as c plus b plus a. The identity property for addition is if you add 0, the number stays the same. The identity property for multiplication is that if you multiply by 1, the number stays the same. The inverse property for addition is such that you add the opposite, or what we call the additive inverse. 4 plus negative 4 equals 0. So the inverse of 4 is negative 4. The inverse of negative 8 is positive 8. The multiplicative inverse of a number is what we call the reciprocal. So if you have 5, the multiplicative inverse is 1/5. If you have 3, the multiplicative inverse is 1/3. If you have 1/2, the multiplicative inverse is 2, or 2 over 1. In this section, you will be taking a look at tables, such as the one you see in front of you, and be asked to take a look to see if each of those properties holds true. This particular question asks us to tell if the set is closed under the operation of block addition. What that means is, if it's closed, and we only started with 0, 1, 2, 3, 4, 5, 6, 7, the only thing you would see inside the table here would be 0s, 1s, 2s, 3s, 4s, 5s, 6s, and 7s, which we do see. That means the system is closed. No other numbers are available. All we have to work with are 0s to 7s. If we're looking here, at this one, we now see shapes instead of addition or subtraction or things that we're familiar with. That is irrelevant. What we do need to do is take a look to see at what the connections are. So for example, inside the parentheses here, we're saying b square a. So we look at the square table, we look at b, and then we line up under a to determine what the value that is. So b square a is equal to b. Then c triangle b indicates c. Then we look at the other side to see if that's the same. C triangle B equals C. C triangle A equals A. So we have C and A with a square in between them. So C and A equals C. So are the two sides the same? Yes or no? So we want to think about what property is displayed. Well, it kind of looks like, if you think about this as 4 times x plus 2, we're looking at the distributive property. Similar type of question. C triangle C. C triangle C is E. So C square E is B. And then C triangle B is C. Then it asks us to replace X with A, B, C, D, or E to form a true statement. So what letter, when we use the operation square, with B do we get D? Let's see, B to get D. Well, here's D in our table, so that would indicate that we have to cross it with C. Here's another table. Replace X with A, B, C, D, or E to form a true statement. X cross B is E. So B cross something is E, results in E. So B cross D. Take your time and read your tables carefully. Find the inverse of 8 in a 10-hour clock system. So let's take a look at the 10-hour clock. Now remember, the inverse is what do I need to add to the number to get 0? Now in real numbers, the inverse of 8 is -8. But on the clock, it's asking us what do I need to do to get back to the 0 marker. So if I'm on 8 o'clock system, what do I need to add to get back to 0? And the answer is 2.